Good morning, students. Your teacher here, Mr. Sarasinski, with our Module 4 review. Remember, this is our easy test, so let's get ready to have a good day tomorrow when we take it. Starting with exponent rules. So product rule says if you have two variables being multiplied with the same base, you add the exponents. So x to the a plus b. Power rule says if you've got a variable with an exponent being raised to a power, then we multiply the exponents, a times b. Quotient rule is the opposite of the product rule. So when you divide, you subtract. And the negative exponent rule says it goes to where it is not. So if it's in the numerator, you move it to the denominator and the negative goes away. If it's already in the denominator, you move it to the numerator and the negative goes away. And then what about adding and subtracting? Well, when you add and subtract, variables and exponents do not change. Add the coefficients only. Okay, so here we go. Simplify each expression completely. Final answer should contain only positive exponents. So if you got a negative exponent, you're not done. All right, here we go. 6ab minus 8ab. They are like terms. So 6 minus 8 is negative 2ab. Number 2. My like terms are the first and third term. Negative 2xy squared plus 6xy squared is 4xy squared minus 4xy. Number 3, subtract from turnaround phrase. So we don't write it the way it's written, we write it backwards. So 8b5 minus negative 6b5, and minus a negative is like plus a positive 14b5. Number 4, multiply the coefficients, add the exponents, that's negative 35, n to the negative 6, and then the negative exponent moves down. Okay. Number 5, power rule first. That's 25v to the 8th times 2v to the 3rd times v to the 1st. 25 times 2 is 50. And then add up all your exponents. So v to the 8th plus 3 plus 1 is v to the 12th. Number 6, power rule first. Negative 1 squared is positive 1. A to the 6th times 2 is a to the 12th. And b to the 1st times 2 is b to the 2nd. Plus 9, a to the 12th, b to the 2nd. And those are like terms. So 1 plus 9 is 10, a 12th, b to the 2nd. Number 7. All right, power rule first. So this is x to the 1st times 2, that's x squared. Y to the 3rd times 2 is y to the 6th. And then we're going to complete the product rule. Negative 2 x to the 2nd. And then we got to add the y's. That's y to the 10th. And let's bring this down. Minus 13 x to the 2nd, y to the 10th. And those are like terms. So negative 2 minus 13 is negative 15 x squared, y to the 10th. 8, subtract the exponents. 6 minus 5 is r to the 1st. 7 minus 4 is s to the 3rd. And 2 minus 2, the t's go away. Number 9, power rule in the numerator, then product rule in the denominator. So here we go. Negative 3 squared is positive 9. 6 times 2 is x to the 12th. 5 times 3 is 15, and x to the 3rd times x to the 3rd is x to the 6th. We add the exponents. All right, now simplify 9 divided by 15. They reduce by 3. So that's 3/5. And then x to the 12th minus 6 is x to the 6th. Positive exponents go in the numerator. There's a fraction. Number 10, everything gets the exponent. And there's actually a couple schools of thought here. You can reduce what's inside using the quotient rule first and then do the power rule. In this example only does that work. But since we've been doing it, just kind of distributing that 2 to everything, I'm just going to keep doing that. So we've got 4 squared, which is 16. X to the 4th times 2, which is 8, and y to the 2nd times 2, which is 4, over 6 squared, which is 36, x to the 1st times 2, y to the 1st times 2. All right, so this will reduce by 4. 4 goes into 16 4 times, goes into 36 9 times, so 4 over 9. X to the 8th minus 2 is x to the 6th, and y to the 4th minus 2 is y to the 2nd. Okay. Number 12, product rule in the numerator, quotient rule, and then negative exponent rule. Here we go. 7 times 3 is 21. Negative 8 plus negative 2 is negative 10, divided by 6k to the 2nd. And when you divide, let's see, we'll reduce this. 3 goes into 21 7 times and 6 2 times. And then k to the 10th minus 2 is k to the negative 12th. And so we're going to put that in the denominator, and the negative goes away. Number 12, negative 9 divided by 27. That reduces to negative 1/3. And then n to the 8th divided by n to the 10th is n to the negative 2 power. And negative exponents move to the denominator. Negative goes away. All right, that is exponent rules. Moving on, graphing exponential functions. Okay, so there is the equation. Remember, if b is greater than 1, it's growth. And if it's a fraction less than 1, it's decay. K is the value of the range and the asymptote. Remember, range is always y is greater than, asymptote is always y equals. And the domain is all real numbers. The y-intercept you have to find in the table. And we're going to use the same 5 values every time. All right, now looking at our first equation. This is negative 4, and it's greater than 1, so I know it's growth. I know the domain is all real numbers. I know the range is y is greater than negative 4, and I know the asymptote is y equals negative 4. All right, now I'm going to pause and put this in my calculator and come back and finish. All right, so for negative 2, we have negative 3.8 repeating. Negative 1 is negative 3.6 repeating. 0 is negative 3. 1 is negative 1, and 2 is 5. So it looks like my y-intercept is going to be at 0, negative 3. All right, my asymptote, I'm going to go ahead and put on here. It's at y equals negative 4. And now my 5 points, negative 2, negative 3.8. Well, negative 2, negative 3.8 is really close to negative 4. Then negative 3.6, it goes up just a little bit, and then negative 3. 1, negative 1, and then 2, 5. So you can see this is starting to increase now pretty fast. Connect the dots. And there is your graph. Number 26, look at the equation. It's 1/4 being raised to the x power. That's decay. Domain is all real numbers. There's no k, so remember, if there's no k, k is 0. y is greater than 0, y equals 0. Now let's go find the y-intercept and our 5 points. And when you put that in your calculator, you should get -2, let me put those down here, 8, 2.5, 0.125, and 0.03125. All right, so on the graph, we have an asymptote at 0. Now, -2, 8, -1, 2, 0.5, and then it's getting smaller. Okay. And our y-intercept is at 0.5. All right, that was graphing. Now, given the exponential function, identify the rate of growth or decay. Now, I taught you exponential growth and decay, and the exponential growth formula says that if the function is increasing, then you would add the rate to r. And if the function is decreasing, then you would subtract the rate from from 1. I said r both times, it's 1. So looking at these functions, I can tell very quickly if they're growth or decay. This is growth because it's greater than 1. This is decay because it's less than 1. And this is decay because it's less than 1. But what I want from you is for you to be able to tell me the percent that it's either increasing or decreasing by. And so for growth, that's the number that you added to 1. And then for decay, that's the number that you subtracted from 1, converted back to a percent. So in number 1, it's very easy. I can tell this is 0.75 more than 1. So this is increasing by 75%. Number 28, I have to do some work because this is decay. So 1 minus 0.88 equals 0.12. So this is decreasing by 12%. And then 1 minus 0.95 is 0.05. So this is decreasing by 5%. You will have, I think, 3 of these on your test, at least 2. So make sure you understand how to calculate the percentage of growth or decay. All right, now a couple growth and decay problems, one of each on your test. You need the initial amount, the rate as a percent or as a decimal, and then t is time. So we've got 13,000. We've got 15% as a decimal is 0.15. And then it's 5 years. So here we go. Y equals 13,000 times 1. Now, since this one is depreciating, we have to subtract 0.15 raised to the 5th power. So that's 13,000 times 0.85 raised to the 5th power. And when you do that, you get $5,768.17. All right, number 30, Scott purchased a painting in 2006 for $1,250. So A is $1,250. Its value has increased. That's how I know it's growth by 6%. R is 6%. As a decimal, that's 0.06. Use an exponential function to find the value in 2017. So we got to do some work for the time. 17 minus 2006 is 11. And so now I can write the function y equals 1,250 times 1 plus 0.06 raised to the 11th power. That's 1,250 times 1.06 raised to the 11th power, which is $2,372.87. All right, moving on. Topic 4. Classifying polynomials, and you were to classify them by degree and by number of terms. And degree is starting with 0, constant, 1 linear, 2 quadratic, 3 cubic, 4 quartic, and 5 quintic. And number of terms, 1 monomial, 2 binomial, 3 trinomial, and 4 or more polynomial. So for number 1, actually 3, the highest exponent is 1, so this is linear. And there's 2 terms, that's a linear binomial. Number 5, the highest exponent is 2, so that's quadratic. And there are 1, 2, 3 terms, so that's a quadratic trinomial. Those are the ones we're going to study in our next module. All right, no exponent, that means it's a constant. And there's only 1 term, so this is a constant monomial. And number 6, the highest exponent is 4, so that is a quartic. And there's 1, 2, 3, 4, 5 terms, so that's a quartic polynomial. All right. Topic 5, simplifying monomials. So let's talk about what we've done here. We've done adding and subtracting. We've done multiplying monomials by polynomials and dividing monomials by polynomials. And we've done multiplying binomials by binomials and binomials by trinomials. So all of that can be in here. All right, so we're starting with subtraction. And when I taught you this, I taught you to distribute. You have to distribute those negatives because it changes the sign of everything in the second parentheses. Now we can combine like terms. 2x squared minus x squared is just x squared. Mark them out. 3x plus 4x is 7x. And 2 plus 1 is 3. That is subtracting. Number 8. First, we have to distribute the monomial. Then we're adding. So 2 times 5 is 10. 8 to the third times 8 to the second. We add the exponents. 2 times negative 7 is negative 14. And 8 to the third times 8 to the first is 8 to the fourth. All right, now I'm going to rewrite the rest. And we can start to combine like terms. So 10 8 to the fifth minus 8 to the fifth is 9 8 to the fifth. And negative 14 8 to the fourth plus 3 8 to the fourth, not positive, negative 11 a to the fourth. Number 9, multiplying a monomial by a trinomial. Here we go. 5 times 9 is 45. C to the second times c to the second, c to the fourth. D to the first times d to the second is d to the third. Minus 5 times 4 is 20. C to the fifth, d to the second. Minus 10, c squared d. And we can't combine anything. All the variables have different exponents. So all we can do is leave it like that in simplest form. Number 10, distribute 2 times. Then let's see if we can combine some like terms. We've got negative 20 y squared plus 44y. Now I'll distribute the second one, and we get negative 6y, that's y squared, and negative 20y. Now we can combine like terms. So negative 20y squared minus 6y squared is negative 26y squared, and 44y minus 20y is not 20, 24y. Okay. Number 11, this is what we did yesterday. So x times x, 4x is 4x squared. Remember, we're just distributing the first term to everything in the second binomial, and then we're going to do the same thing with the second term. So x times negative 3 is negative 3x. Now the negative 1, that's negative 4x, and that's positive 3. So negative 3 minus 4 is negative 7x. Remember, those inside terms will always combine. Number 11, we have to expand first, or I'm sorry, this is 12. 5y minus 1 times 5y minus 1. That's all exponents tell us to do. Multiply something by itself. And now we can distribute. And that's 25y squared minus 5y minus 5y plus 1. And this is actually a perfect square trinomial. Combine like terms and you get negative 10y. All right, 13. 2x times x, 2x squared. 2x times negative 3y is negative 6xy. 5y times x is 5xy, and 5 times negative 3y is negative 15y. Two inside terms will combine, so we get 2x squared minus xy minus 15y squared. Actually missed the squared there. Okay, 14. All right, we're binomial times binomial, and then we have something to add. That's interesting. X times 4x is 4x squared. X times negative 2 is negative 2x. Now, 4 times 4x is 16x. And 4 times negative 2 is negative 8. Minus 2x squared. Bring everything down. Now let's combine. 4x squared minus 2x squared is 2x squared. 2x, negative 2x plus 16x is 14x minus 8. Number 15, divide. And when I taught you this, I taught you to write them separately, but you can do whatever you choose here. Okay, so what I would probably do is negative 8x to the 5th divided by 4x to the 3rd plus 28x to the 4th divided by 4x to the 3rd minus 4x to the 3rd divided by 4x to the 3rd. All right, one at a time. Coefficients first, subtract the exponents. Negative 8 divided by 4 is negative 2x squared. Plus 28 divided by 4 is 7, and x to the 1st, and 4x to the 3rd divided by 4x to the 3rd is just 1. 16, same thing. 27 c to the 4th d to the 7th divided by 3 c to the 2nd d to the 3rd plus 15 c to the 3rd d to the 5th divided by 3 c to the 2nd d to the 3rd. All right. Coefficients, subtract the exponents. 27 divided by 3 is 9. C squared d to the 4th. 15 divided by 3 is 5. C to the 1st, d to the 2nd. Those are not like terms, so they will not combine. All right, geometric applications. You will have one of these on your test. Okay. Write an expression to represent the area of the rectangle below in simplest form. All right, so area, remember, is just length times width, and it doesn't matter which one you use, really. We just need to multiply the two. So 4x plus 1 times x squared minus x plus 3. And we're just distributing here. That's going to be 4x cubed minus 4x squared plus 12x. When you're doing this, don't forget about your exponents. All right, you got to go slow and steady with this. All right, now 1, that's x squared minus x plus 3. Now we can combine like terms. Remember, the first term isn't going to have anything to combine with, nor is the last term. So negative 4x squared plus x squared is negative 3x squared. 12x minus x, 11x plus 3. And number 18, this is where you need to find the area of the shaded region. And the way to do that is to find the area of the larger rectangle and subtract it from the area of the smaller rectangle. So the area of the larger rectangle would be x times x plus 2. And the area of the smaller rectangle would be 7 times 3. All right, so let's distribute first. Simplify for the larger. We get x squared plus 2x minus 21. So that's it. I don't have to distribute this negative, even though normally in the examples we did in the notes we had to. This is just x squared plus 2x minus 21. All right, next page. These are the TN Ready style questions that I wanted to add onto here so you could see kind of what you might expect on the test. So write an expression that could model the area of the following square, and typically this is going to say in simplest form. So area of a square is similar to a rectangle. I mean, you could use length times width, but also it's actually just length times length, right? Because all the sides of a square are the same. And if you're multiplying something by itself, it's kind of like squaring it. So this is like a equals 2x minus 5 squared, which is 2x minus 5 times 2x minus 5. And you guys know how to simplify that now. That's 4x squared minus 10x plus 25. 4x squared minus 20x plus 25. Number 2, find the perimeter of the quadrilateral. Well, perimeter is just building a fence, so you just add up the sides. X squared plus 6, or minus 6, plus 2x plus 5, plus x squared minus 3x, plus 4x squared plus 2x. And now I just need to combine like terms. So x squared, x squared, x squared. 1 plus 1 plus 4 is 6x squared. Now the x's. 2x minus 3 is negative 1, plus 2 is positive 1, minus 6 plus 5 is negative 1. That is the perimeter of the quadrilateral. All right, number 3, and this is very common on the test, so I want you to really feel this question, okay? This is a lot of work, but it also is a lot of points on your test. So this is the type of question that would be worth, more points because of the rigor involved. So Emily realizes that the expression can be written in many equivalent ways. Select all expressions below that are equivalent. And I'm seeing in this that it looks like when I downloaded this, it didn't print or do it correctly. So there should be an expression right here that is x squared plus 4x plus 3. And so I have to find all the equivalent answers. And I'm going to be using all the things that we've been learning in this module. So x times x, I have to simplify each one of these. X squared, x times 1, 1x, 3x, 3, that's x squared plus 4x plus 3, and that is the same, so it is equivalent. All right, B, x times x squared is x cubed, and x times 4x is 4x squared plus 3. No, the exponents are too high. Can't use that one. All right, we're subtracting in C, so we need to distribute the negative. That's negative x squared minus x plus 6. Now we combine like terms. 2x squared minus x squared is x squared. 5x minus x is 4x. And negative 3 plus 6 is 3. So C is equivalent. D, x times x is x squared. X times 1, 1x. 4 times x is 4x. And 4 times 1 is 4. That's x squared plus 5x plus 4. Not equivalent. And the last one, we're adding x squared. Didn't have anything to combine with. 5x plus x is 6x. and 2 plus 1 is 3, not equivalent. So A and C are the answers. Those are the only two that when I completed the operation had the same expression. All right, last one. We're comparing a table of values to a graph. And this is common on the TN Ready. They want you to be able to compare these two different types of representations. On the left, I can see that the rate of change is adding 1 and adding 4. So that's 4 over 1, which is just 4. And that means that this is not exponential. I can tell from the graph that that is exponential. But if it's increasing by the same amount each time, this one is going to be linear. All right. So it says, which has the greater y-intercept? Well, I know the y-intercept is where x is 0. So my linear function has a y-intercept of 0, 9. And it looks like my exponential function crosses the y-axis at 4. So it has a y-intercept of 0, 4. And so the linear function has the larger y-intercept. What type of function is represented in B? That is exponential. And you can tell just from the graph. And what is the equation for the function represented in A? Okay, so we know the rate of change. And we know the y-intercept, and that's all you need. So y equals 4x plus 9. Remember that slope-intercept form where m is the slope and b is the y-intercept. I am your teacher. This is the way. Good luck on your test tomorrow.